Hello, I'm Stephanie Rensink and I will present you our research on the application of a bio-based coating for wood as a construction material, fire retardancy and impact on performance characteristics. In the development of new products, sustainability and functionality become more relevant. Wood is an important renewable material, but like all natural substances, it is subjected to degradation, and also fire is a potential risk. In timber, the use of fire retardants are usually necessary, but the use of fire retardants is often disadvantageous due to related environmental pollution. Recently, an environmental friendly concept to protect wood is on the market and is called xylobiofinish. It consists of a linseed oil treatment and a microbial coating based on the fungus Aureobasidium pullulans. Previous research showed that this biofinish in combination with an ammonium phosphate-based fire retardant contributed positively to the fire retardants and achieved a fire resistance class B. In this study, the aim is to achieve information about the initial effect of the biofinish in combination with a fire retardant on timber surfaces. For testing this, we've used samples of micro-riveled Scots pine and first impregnated the samples with an ammonium phosphate-based fire retardant. Then we've treated the samples with linseed oil and added the microbial coating to the wood. Some samples were exposed outdoors and other samples were exposed indoors for 12 months. The sample weights were determined after climatizing to equilibrium moisture content at 23 degrees and 65% relative humidity and after 18-hour incubation at 103 degrees. After exposure, we found an EMC for indoor samples of 9.3% and outdoor samples of 10.3%. In comparison with literature, it was expected that untreated Scots pine would have an EMC of 11.5%. Similar lower EMC results were shown by Stevens et al., who showed lower EMC contents in wood treated with chemically reactive phosphorus acids. However, other literature showed that ammonium phosphate could increase the moisture content in wood. The lower moisture content found in these samples could be attributed to the reaction with hydroxyl groups or the hydrophobating effects of linseed oil. Also, what we saw in the samples was that after exposure, the samples had a weight reduction of 23.4 grams, which means a considerable loss of 57%. Also, no degradation of the wood or loss of biofinish was noticed, and similar fire retardant leaching results were found in a previous in vitro study. Therefore, we're expecting that the weight loss is mainly contributed to fire retardant components. Also, we saw a serious impact of ammonium phosphate treatment on the timber in the form of cracks, what we can see in photo A until D. Photo E shows us a wood sample with biofinish, but without fire retardant, and those samples didn't show cracks. If we have a closer look at the microscopic photos, we see in photo A, wood treated with biofinish and no fire retardant. Photo B until D shows us samples with fire retardant and biofinish, and photo E shows us samples with only a treatment of fire retardant. Some possible phosphate salt particles were shown in photo B and cracks of widths of almost a half millimeter and 0.38 millimeter in photo C and D. So, in conclusion, we saw that the biofinish with an ammonium phosphate-based fire retardant contribute to a fire resistance class B, but in outdoor exposure, crack formation and leaching was noticed. From some phosphorus-based fire retardants, it is known that they could induce the reduction in strength of the wood. So, further research to prevent crack formation and leaching is needed. Also, in a previous in vitro study, we saw that an extra linseed oil top coating could reduce leaching in a watery environment. So, thank you for your attention, and if you have any questions, please send me an email.